This is a brief demonstration of the FAST scheduling system. The system schedules activities. An activity is anything that takes time to perform. Usually, activities require resources that must be available. Stated differently, the lack of availability of a resource constrains the schedule. One of the features of the FAST system that makes it unique is its ability to define activities that are realistic in their detail. To demonstrate this, let's create an activity that is typical of what you might see in a manufacturing environment. We'll call the activity Lathe Operation 1, and we'll specify an early start time as 7:30 a.m. on March 17th, a latest finish time of 3 p.m. on the same day, and a duration of 47 minutes. Let's also assume that it takes a machinist, any from a qualified group, and that the activity is computer controlled so that the machinist is needed only for the first 18 minutes and again for the last 5 minutes of the activity. We should note here that the times can be specified as any values, not limited to specific intervals such as 5-minute intervals, 15-minute intervals, etc., as required by a spreadsheet or many other scheduling approaches. In scheduling jargon, we say that the FAST scheduler does not use time buckets like many spreadsheet or similar scheduling techniques require. Instead, it treats time as a continuous variable with any values that you want to specify. Of course, it's best to include all resources that are potentially limited and, if unavailable, could keep the activity from being done. Continuing with the activity definition, let's assume that it also requires a caliper kit for the last 5 minutes. Finally, let's also assume that Lathe Operation 1 also requires cutting oil in different quantities over the duration of the activity. This is a more detailed definition of an activity than most software schedulers can handle. But this level of detail is realistic because any one of these resources could have limited availability and could constrain the scheduling process. Note that we're including here what are sometimes called pooled resources, and we are allowing them to be used intermittently within an activity and in time-varying quantities. I've gone ahead and scheduled this activity just to show how it obligates the required resources. Notice the notches in the usage profile, which correspond to the requirements that we defined. If we scheduled multiple activities using cutting oil, the system would add the profiles together and enforce the constraint on the total use. Of course, if an activity is unscheduled, it will add the usage profile back into the availability of the resources. Now, obviously, before we scheduled this activity, we had to define the original availability for its required resources. We did this using the resource profile editor, which functions in a manner very similar to the activity editor. So that's how you define activities. Obviously, we can define as many required resources as necessary to constrain the schedule. This is the same as populating a spreadsheet, except that here you don't have to worry about the fact that different activities may require different numbers of resources, which in a spreadsheet makes it difficult to determine the right number of rows and columns needed to define the activity. Once a timeline is built, we can see the resource utilization for any resource on a timeline display as shown. We should also note here that we could have relaxed certain constraints, thereby allowing overutilization to be visualized on this display. This is especially helpful when determining the needs for additional resources, for finding bottlenecks, and for doing what-if planning. You can see that the FAST system provides a very rich level of flexibility and detail in describing an operational environment. Now let's look at a more complete description of a scheduling environment. We'll switch to a medical example. This is the main page for scheduling. The main page shows a timeline with scheduled activities shown as blue bars. Each line shows assignments for a specific resource. Green indicates availability for this resource. We can change which resource we want to see using the pull-down menus above the timeline. Notice that by dragging the cursor over any assignment on the timeline, the system will show you the activity that is causing that resource to be used. On the left of the main page is a list of activities that we're working with. We can see a list of activities already on the timeline or a list of activities that are not yet on the timeline. We call these two lists the scheduled list and the not scheduled list. Activities move from one list to another as we schedule or unschedule them. Let's start the demonstration by unscheduling everything. From the scheduled list, we'll select all and then hit the Unschedule button. In this example, we have modeled a hospital that is scheduling surgical procedures. Each procedure requires a surgeon, an operating room called an AIP, and sometimes some special equipment. Of course, all of these resources have limited availability. Here, the patient names are used to identify the activities. Of course, in different applications, you can use any unique identifiers as activity names. Although in this demo, the procedures are typical for a hospital, the names of the patients and the physicians are, of course, fictitious. The hospital is granted privileges to use the operating rooms to each medical specialty only at specified times of the week. For example, orthopedic doctors can use the operating rooms only on Mondays and Wednesday afternoons. Ophthalmologists get Tuesdays, and so forth. To accommodate this restriction, we've included what the hospital calls block times and made them resources that are available only when the permissions are granted. In this hospital example, different priorities are assigned to different procedures. You can select as many priority levels as you wish. In the example, we have used 3 levels. We have used the number 1 as the highest priority, 500 as the second priority, and 999 as the lowest priority. You can use intermediate values like 100 if you want to create more levels at a later time. Now let's schedule the activities with the 2 highest priorities and see what happens. To find these activities, we use a filter built into the main page. On the timeline at the right, we see a list of all the operating rooms and when the scheduler has assigned procedures to them. Assignments are shown in blue. We can also look at the physician's schedules by changing the display. For example, we can see that Dr. Reynolds is performing several surgeries during the time allotted to the specialty otolaryngology. Let's go back now to the operating room schedule. Since the schedule isn't saturated, let's select more activities and schedule them also. Note that we have created a list of activities that is much larger than the capacity of the resources. Because of this, the scheduler schedules as many activities as possible, but leaves several on the not scheduled list. By moving the cursor over an activity on that list, we can see the first constraint that the scheduler found that made the activity infeasible. For example, here's an activity that needed a doctor who was not available within the same time window. Now let's talk a little about conflict resolution. Let's assume that some activity that's not on the schedule has become very important and we want to get it onto the timeline. For simplicity, let's assume that the activity already resides on the not scheduled list, and in this example is identified as Tess Latimer. We're interested in when we could possibly schedule her procedure. One way to get that activity scheduled is by freeing up the resources it requires. By going to the activity editor for that activity, we see a possibilities button. If there were any times that the activity could be scheduled, they would show up here. We could select any one of the possibilities and schedule the activity. However, in this case, we already know that the scheduler couldn't find the resources needed to schedule the test Latimer activity. Note that the activity requires Dr. Reynolds. So let's go to the timeline to see what Dr. Reynolds is doing during the times that the activity was requested. We see that he's performing surgery on Tia Krestovich during the allotted block time. We decide to try a strategy that unschedules the Krestovich activity, thereby freeing up Dr. Reynolds. So we start by unscheduling the Krestovich activity. Note that it now reappears on the not scheduled list as expected. We can now schedule the Latimer activity by simply selecting it from the not scheduled list and hitting the schedule button. Now let's assume that an alternative physician is acceptable for the Krestovich activity. Of course, the new physician would have to have the same specialty as the original physician. One way to find a feasible alternative is to use the wildcard capability of the system. Let's replace the requested physician, Dr. Reynolds, with a wildcard. With this change, the original activity can now be scheduled. We select one of the possibilities. We can see that the activity is now scheduled with Dr. Miele as the resource. Without going into many more complicated scenarios, you can see by easy manipulation, you can manage the conflict resolution process, add and subtract any combination of activities, fill holes in the timeline, and use both automated and manual procedures to develop the desired timeline. The scheduling can be as batch-oriented or as manually oriented as your work environment requires. Now, a final comment. Schedules almost always change, and a history of their revisions is helpful. For example, perhaps you need to keep track of the as-planned versus the as-performed schedule. To assist in this bookkeeping, the system has a built-in change log that keeps track of all the changes made, when they were made, and by which user they were made. Many users update their plans to correspond to actual activities for historical reasons or for assuring that their billing is correct. Although there are many more features available to you as a user of the FAST Scheduler, we hope this short video has demonstrated its versatility and its ability to handle both the simple and most challenging scheduling environments. We encourage you to read through the FAQs. If you have unanswered questions, please contact us. We will assist you in setting up your scheduling description and a description that truly matches your operational environment. Once your initial setup is done, it's easy to use the system for your routine scheduling or for helping you with your strategic planning.